Hello, today we are looking at the center of mass, and very simply the center of mass means the point at which the mass of an object may be thought to be concentrated. So to understand this a bit better, let's have a look at an example of a wooden plank. So here I've got a wooden plank, and the center of mass for this wooden plank is around about here. That's right about in the center there, and this is the point where we think the mass could be concentrated if it was concentrated in one point. Now it's important to remember that all the mass isn't actually concentrated here. The mass is spread throughout the object, but if there was a single point where we could think of it to be concentrated, that would be called the center of mass, and we could test this out by actually hanging or suspending it from a string. So if we suspended this plank from this point here, it would stay balanced and it would stay in the air. So that's how we see the center of mass for this particular object. Now this leads us to a second scenario. If we've got a freely suspended object, in this case I've taken an example of a boy on a swing. He is freely suspended, and most of the time he's happily swinging backwards and forwards, but if we allow him to come to rest, which means to stop moving, an important point to remember is that the center of mass is directly below the point of suspension. So the point of suspension here is at the top, and the center of mass will be directly below. So it'll be somewhere along here, probably around about here for this boy. But the key point to remember is that it's directly below the point where it's hanging from. We could look at yet another example. This is an example of a hanging basket. We can see that it's suspended from this point here, and the center of mass for this would be directly below. So again, we could estimate for this basket it would be round about here, but it's directly below the point where it is suspended. The next thing we want to work out is how we find the center of mass for a flat object such as a piece of paper. So here I've got some paper, and because it's a regular shape, this has lines of symmetry. So the lines of symmetry for this piece of paper will be straight down the middle there and straight across the middle from that direction. So the center of mass would be right there, and we could actually put this flat, put maybe your finger underneath it, and this would balance and stay suspended if you held it from that point. Similar idea with a square piece of paper. Very simple. The center of mass would be right there. Go through the lines of symmetry and you will find the center of mass. But what happens if we've got an irregular shaped flat piece of paper, or an irregular shaped flat object? There's a certain method you can use to find the center of mass for this object, and it's something that you need to know how to do. So let's have a look at that. What we need to use is something called a plumb line. And a plumb line is just very basically a string with a weight attached to it, and this string with a weight attached to it, if it's allowed to be freely suspended, it's allowed to move while it's hanging, will point directly towards the center of the earth, so it'll point directly downwards. So we can take our irregular shaped piece of paper, we can suspend it with this is like a drawing pin or something that's just holding it in that position. The piece of paper must be freely suspended so it can come to rest at its natural resting point, and the plumb line also must be free to move as well. And once we've done that, we can then draw in a line. So we would have a line that would follow that plumb line. You could probably just draw a dot, two dots, one at the top, one at the bottom, just under the line, and you could then join them up. The second thing you do then is to dangle it from a second position. So here's our first line that we drew for the first point of suspension. We can then dangle it from a second position, and we would draw our line in again as we did before, and then the point where these two lines cross, that would be the center of mass right there. Now we could do just one more just to make sure. So again, I've dangled it from a different position now, and you can see the plumb line goes through the intersect there. So we can see that the center of mass for this object is right there. So one of the things that you must be able to do is to describe how to find the center of mass of a thin, irregular sheet of material, whether it's paper or plastic or whatever it is. You should be able to describe this method to find the center of mass, and it's quite straightforward. You can imagine this would be worth possibly up to 3, maybe 4 marks in an exam, and it's quite easy to describe, so it's worth just making a note of how you do that. But that's me done for this video, just a quick one about center of mass. Thank you for watching, and I'll see you in the next video.